so folks can listen to later. Awesome. Well, thanks everyone for joining. I'm Sally Ann. I work on the product team here at Rise, and I have Aman with me. Do you want to do a quick intro?
Yeah. Hey, folks. My name's Aman. I'm also on the product team, working very closely with Sally Ann. These days, a lot on the LLM and generative side of the world.
Totally, yeah. So a lot of our day is working, thinking about LLMs. And we have a really good paper today, ReAct. It's a prompting technique, and we'll also cover some other prompting techniques. So just kind of to give you an idea of what our agenda looks like, we're going to read using lately. We're going to show you some of the best parts of the paper. We also have a coding example with ReAct, super simple implementation using OpenAI's API. So looking forward to that. And then we might cover in go into some other prompting techniques like chain of thought. I think we're actually going to focus a lot on reflection. So yeah, with that, we can kind of get to it. So what is ReAct? So ReAct, the title, it comes from the idea that the researchers were really trying to mimic the way that human intelligence works. So if you think about any time a human's given a problem or they're trying to learn something, they kind of reason through something and then they take an action. So this is something that they were trying to bring to LLMs. And so ReAct comes from having a reason component of the prompt and then a act component of the prompt. So the whole concept is it integrates reasoning with these actionable outputs. And so it allows language models to interact with external environments to retrieve information. So that's going to be the action part of that. So you can think of that as like calling a tool or a function to get some kind of information to then, reason about. It's kind of this cyclic loop of reasoning, taking action until eventually the LLM comes to an answer. So I kind of hinted on this. The main goal of all this research was to enhance those task solving abilities by mimicking human intelligence. Something I always find interesting, I'd love to kind of get your take on is, human intelligence is like, it's always our gold standard. Like with every paper that we read, there's some kind of human intelligence, human reasoning that we're really trying to like emulate. And I just find that so interesting. And I feel like it's always been the backbone a little bit to machine learning is like, how like neural networks they're mimicked off the brain. So I just love seeing this, and it just makes so much sense to me when researchers come up with these new principles just to do what humans do.
Yeah, and what's funny is like I've been spending more and more time, maybe folks on the call can relate to with all of the latest. I mean, in the last week of LLM news, it's been obviously an interesting one with Llama 3, a lot of really interesting sort of, kind of information from the researchers and from Mark Zuckerberg on like what the team did to like train that model. And then you had like 5.3, which we might have to come back and revisit. We just did 5.2, it felt like a little while ago, but another small model. It does feel like, what's interesting is you actually have the research side, which is building and training these foundational models. And they're trying to do kind of the same thing, right? Like they're trying to build models that have some level of what we kind of understand to be like human intelligence. Although, yeah, you're stuffing large amounts of data in, you're stuffing in trillions of tokens, but the goal is really to have general levels of human intelligence.
Yeah.
And so they're doing their job of like modeling how the brain works and trying to like, model these like action neurons and, different types of neurons with the neural nets. And then on the prompting side, once you take the output, you're
Hmm.
like, oh, actually, the model out of the box is fine, but it's not good at XYZ things. So we're going to try and optimize it for that. So it's in a way, you could kind of think of it as like fine tuning for almost an application. It's not actually fine tuning, but it's like
Yeah.
in a similar way, it's like, changing the parameters, the output, the input parameters that you're providing to this LLM to actually get some action or output. So yeah, I think it's really interesting. I think that's a lot of what we'll cover is how these different prompting techniques kind of optimize kind of in small ways in their own ways for certain tasks.
Totally. Yeah. It's super interesting. I love your note too of like the coming at it from two different ways. Like there's the modeling aspect of like let's get the models to actually mimic the way the brain works, and there's this prompting side of it of like how can we just take the models because they do pretty well and do it. So we'll definitely dive into that a little bit. So yeah, this is making it more practical for like real world applications. And I think some of the key features of using ReAct are it's suitable for various applications across different domains because it's really just this prompting technique. It quickly adapts to new tasks with minimal data because of the way that the model is being prompted. It really does demonstrate efficient learning capabilities, and I think it just enhances the interpretability. Like we'll see with the coding example, you can kind of exactly track how the LLM is coming to its answer, which is something that I think is a little bit difficult with a lot of these LLMs. Is we don't have like traditional explainability, and not something that's super fleshed out for these LLMs. So like kind of relying on your prompt and getting the response that kind of shows you what the LLM, the journey that it took to come to its answer, I think is something that's pretty cool and powerful.
Yeah, and there's
Um,
even there's like a thread of like even when we get to like interpretability for LLMs, it might actually look like do one of these things, which is like reflect or react and or reason and then act and like, kind of drop all of the steps that you did in between and then use those intermediate steps as a form of like interpretability too. And then we know that like, out of the entire context window, depending on how much of that, it ends up being like self-reinforcement for the LLM to perform a task. Like, yeah, which I'm sure we'll go into. It's really interesting to see like how much is how much of the next action the LLM takes is actually dependent on how it infers how you frame the input prompt in the first place. So yeah.
Totally. Yeah, I think we'll get into that a little bit later in a more detail. But first, like let's like take a look at some of these different methods. So what the paper really aims to do is they put forward this ReAct prompting where they have the thought and action and observation, and it goes in this kind of cyclic manner until it comes to like finish where it actually gives an answer. And they test it up against a few other types of prompting. So there's the standard prompt where you can think of it as just like there's nothing special done. It's kind of like that zero shot type prompting where it's just like, here's do this, no extra information. And then we have the chain of thought, which you can think of this as like reason only. So this is like only give the reasoning behind each step in the prompt. And then they have the opposite side of that, which is just action only. So this is just like kind of where the element is just choosing a tool or choosing some function to call to get some information. It doesn't include the reasoning side of it. So, standard, then the two components, and then we have ReAct. So you can see the examples here. This first one is from Hotspot QA. So this is going to be like a question answering kind of benchmarking. I think it's all based off like Wikipedia questions and answers. There are a variety of different features to this data set. And so this is the one benchmark that they use. And so you can see on the right here, this is like the ReAct prompt. So you can really see the structure that they're putting forward where we have this thought, its initial thought, like, okay, this is the reasoning that I need to go do. I need to figure out this. Then there's the action. Now I'm taking that reason, I'm actually applying it. I'm going to call this function. And then there's this idea of an observation. So they kind of observe the result of the action, which then kind of will kick off the next cycle of doing all of this. So it does it again. So you can see here, first is like, I need to search for the Apple remote and find where it was originally designed to interact with. So it does a search to like just like a Wikipedia API, and then it comes back, observes that, and then it does another round because it realizes there's this front row software that it needs to get more information. So it does it again, and eventually gets to the bottom, and it's able to actually answer that front row is a software that is controlled by the Apple remote. So
Yeah.
you get that whole list. Yeah, go ahead.
And there's one kind of distinct one sort of distinct property of this data set that I think is really interesting is so Hotpot QA it is like based on it is a sort of this question answering data set. But what's distinct about it is it's actually multi-hop questions.
Mhm.
So as you can see, like each of the basically if you were to try to, it's almost like a trivia type of question, but it's not meant to be direct. It's meant to have like some signal in the question itself about what to go do next. So that's kind of the interesting, I think one interesting aspect of this data set is it's all multi-hop data, meaning
Mhm.
you can't answer the question directly. You have to do something to get the answer. So that's sort of just one interesting call out is that's a really interesting property of this data set and what makes it so sort of interesting to use for agent like types of assessment.
Totally, because it really requires, the LM to fetch multiple pieces of like Wikipedia docs or whatever it is. So that's a really good call out, and it's good for this type of application that ReAct is really being researched on. The other example below is for the decision making part of the research. So the first tasks are kind of like QA, There's some fact checking apps using like Fever. Um, and then there's this World and this, I think it's Web Shop is the name of the second part of it. And so this is where it's needing to make a decision and like kind of take an action. So again, we're not introducing the reasoning only prompting. We're just comparing the act only to ReAct. So we'll get into the details of this a little bit more, but just kind of wanted to show everyone the comparison of the different prompts and answers from them all. Cool. So the reasoning tasks here, you can see that ReAct performs better than action alone on both tasks, but it does lag behind chain of thought for the hotspot QA. So it beats it in Fever, so that fact, that's kind of a known thing with chain of thought. It does suffer with like fact hallucination a little bit. And so that's probably the reason ReAct comes on top is because of that. Those action steps allow it to get that external information, so it's kind of adding more context to the prompt and reducing those hallucinations. But it's, again, the ReAct is still struggling. What I thought was really interesting is they take the combination of ReAct and a chain of thought, and that's actually what yields the best results, and you can kind of see that in this bottom portion here. And I think that's because ReAct relies on the info that's retrieved, and so the chain of thought, I think, helps it when maybe the search wasn't informative, because we see that it struggles when that happens and it doesn't know how to get back on track. And I think the chain of thought helps it kind of more easily just recover and reformulate its thoughts a little bit. But I'd love to take your thought on that, Aman.
Yeah, I think as we'll kind of get further and like you kind of realize, like, we were just catching up right before this, and you had an interesting point, which is like, so just to be clear, it's reasoning and action, and like the action is something that basically the prompting kind of almost like forces the LLM to like take some sort of action, and that's totally true, right? Like the interesting thing about these papers and the academic work is you're often trying to like invent a new form of doing something, of accomplishing some
Mm-hmm.
task. But the simpler you can make it, the more you can make it like fundamental and separate from other prompting techniques, other things, like the more kind of, the more it might stand out in research as well. So it is interesting to see like ReAct plus chain of thought is actually, potentially even more powerful than just straight up ReAct.
Yeah.
And that kind of makes sense because you want to combine these techniques to get the best output depending on, depending on the task you're trying to do. In this case, more complex multi-hop question answering.
Yeah, and I feel like we see that a lot with the prompt engineering techniques. Like a lot of the times, one alone is not the solution. It's a combination depending on what you're trying to do, what problems you're having. So it's interesting to see that kind of pattern emerge here as well. So yeah, this is reasoning. So it's good. It's much better than just standard prompting, but for the question answering, chain of thought has a little bit better of performance there. So that's the results for reasoning. Then we have the decision making. So ReAct performs way better than action alone. I think that's something that's a little bit expected, because if you think about it, with the action alone, like all the LLM's getting is that response from whatever action they take. They don't have any of that kind of additional context from like the chain of thought part of it or the reasoning. It's lacking that completely. So it makes sense in a decision making exercise where it has to go through multiple steps to ultimately make the decision, that action alone would be worse performing. But what's, I think, is something worth calling out is the fact that we're still not close to what the human experts do on this task. So that tells me that we're making progress, but we're probably not actually ending up where we would want in a task like this. Like the whole goal is to mimic human intelligence, right? And this shows us that ReAct, unfortunately, is just not able to do that. And it's kind of not even, close either, which is definitely an interesting point.
Yeah. What is
Um,
the IL plus RL approach there?
yes. So it's imitation learning, and then it's imitation learning plus reinforcement learning. And then Butler is also at the top. There's another imitation learning. And the IM is actually inner monologue, where you can basically think about the whole environment versus just the one piece of it. Um, yeah, so it's pretty interesting that they did add that as an additional kind of variable into all of this. And it looks like it helps somewhat, but not always. You can see in these like um, different what are the features of the data set or different tasks, sorry, um, that it doesn't always help out, but it does for this one here.
Yeah, that's interesting, right? Like they call out specifically, like I thought what was kind of interesting in the paper is they have, React versus chain of thought for
Mhm.
the benchmarks. Then they have a section a little bit below React plus chain of thought performs best for prompting LLMs. And then they decide to, use imitation learning
Mhm.
and IM plus IL, and then at the same time, they kind of introduce this, and they're saying, and I guess the result that they're showing here is, like the base React performs better than
Yeah,
those
by
prompting
itself.
techniques, but yeah, but you're comparing React with inner monologue. It doesn't seem. I mean, it looks like it improves performance a little bit, but you don't see and maybe this is just like a fundamental, like, how imitation learning is, but I don't see a, React plus imitation learning benchmark
Mhm.
there. So I thought that was kind of interesting as well.
Yeah, I did too. It didn't seem like they really elaborated on that either, so I'm not sure if that was just like a choice they made or if maybe um it's not compatible. So that's an interesting thing to call out.
Yeah, totally. I was a little confused. I guess imitation learning being like the training,
Hmm.
fine tuning your training technique there, but like why not just apply React to that? I don't know. So that thought
True.
that was
Yeah,
that
and
was
they
interesting.
we'll get to in the next slide, but they do some fine tuning exercise there, so just adds a little bit more confusing or confusion. We should too bad we didn't get the authors to come join us, then we could have asked them about that decision.
Hmm. Yeah.
Um, Cool. So yeah, so what we covered so far, it is great for those reasoning tasks, decision making. It does better than action alone, but still not where our human experts are. And so let's talk about briefly fine tuning, because I thought this was pretty interesting. So, oops. So React performs the least effectively, like among these four different methods. We have standard, again, that's just no real prompting technique. We have chain of thought, action only, and then React. And so when we're looking just like a base model, and this is all variations of the POM model, um, it really does not perform well. And I think that they call out that it's due to the complexity of learning for both reasoning and actions. But I think the real interesting part is just with like a little bit of fine tuning, like 3,000 examples, not a lot of examples used. It then switches and it outperforms all of the other methods. So we kind of know some of these things like the standard and chain of thought, they tend to work on like memorizing facts, and it does tend to lead to that like fact hallucination. So it's probably a big part of it. Again, with React, it does seem to minimize those hallucinations a little bit. Doesn't There's no world in which I at least think of right now where hallucinations go away, but we can minimize them. And so it just suggests that with further fine tuning, with even like higher quality data, like maybe they could do some work on more examples, and maybe it goes back to the quality of examples used. It just seems to amplify the effects of React, which I think is really interesting. And I actually love to see a lot more research on this here.
Yeah, just to double down on that, like hearing more and more about how the foundation models are using synthetic data generation for, like the base model training. I'm excited to see more of that synthetic data generation going towards fine tuning and then coming back to see how these prompting
Mm-hmm.
techniques actually improve. Because you're right, like that's only 2,000 examples. Like that's like if you turn
Nothing.
on yeah, if you turn on GPT 3.5, and which by the way, like Phi 2 was like most of the data I think it was trained on, like the textbook data was like GPT
Yeah.
3.5. Like it wasn't even like, GPT, like the most capable GPT-4, GPT-4 Turbo. Like, anyone who's really interested in this topic could probably go and like, generate 10,000, 20,000 examples, go back,
Mm-hmm.
run the same benchmark and see, oh, across these different model sizes, does React actually perform? Now you can run it on Llama. And really interesting opportunity to like go back and revisit. It's funny you mentioned right before, Sally, and like, man, this paper is like old. Like, why are we revisiting React? It's from 2022, and I'm like, oh my gosh, like it is. But you're like absolutely right. Like 2022 feels like ages ago when it comes to the
Forever.
space. So, and the data kind of also at
Mm-hmm.
this point is pretty out of date. So, yeah, it would be interesting to come back and revisit that.
Totally. And I think it also highlights the fact that there isn't this like silver bullet when it comes to making these models perform well. And I think this kind of highlights it too of like we were talking about before, it's a combination of prompt engineering techniques. It's fine tuning, it's the models, it's all of it together. And I think that's an important thing to kind of hit on there. Cool. Let's look at a coding example. So we want to really show y'all how easy it is to really implement this example. So we'll drop the notebook so everyone here can try it out. But this is just an example. There is this learning log here that we used as inspiration for this, but showing you how easy it is to get started with this type of application. So kind of traditional standard installation of just getting your OpenAI, getting some packages, and then you define just a basic chatbot class. So this is just going to manage our conversation flow. You can see I'm really just setting up that chat client with OpenAI there. I'm using 3.5 Turbo right now. You can even add in some kind of logging to see how many tokens you're using. And then we set up a very basic prompt. So reading through this, we're setting the scene that the LLM is to go through this loop of thought, action, pause, and observation. So the pause is when it's actually calling that function or taking that action there. And then the observation is that the output of the action and observing whether or not it needs to kind of loop again. And so at the end of the loop, it's saying, give us the answer. And it actually outlines the action. So this is a very simple example. Again, we grabbed this from that great log at the top. And so it's calculate. So this is like some kind of mathematic operation. There's a Wikipedia call, so I can access the Wikipedia API to do like a search. There's a blog search that can be done. And then it gives it some guidelines. So like always look through things on Wikipedia if you have the opportunity to, and it actually gives an example session for the LLM to fall. So you can see that's not a lot of prompt writing. Again, this is a very simple example, but like that's pretty straightforward, and you can see there's not much more to it from here. So we basically
Sure,
have
and
this query. Yeah,
to
please.
pause on that for a sec, I do think it's interesting. Like it often comes up, like should I be providing examples in the prompt? Like yes, single shot, multi-shot. Like provide examples. You'll see, like without the examples, it would be pretty tough to, I think, for the the LLM to infer what you mean by take an action.
Yeah.
So you do definitely need examples in the prompt, some shots.
That's a really, really great call out there. I definitely think it would be confused. That would be an interesting experiment to see if we take that out and put it back and see if it could
Zero shot,
replicate it.
single
Yeah,
shot, few shot. Yeah.
it would be interesting to see. But yeah, that's the prompt there. And then we just have this kind of simple query function that actually, starts the querying process when a user wants to ask a question. And then we have our actual action handlers. These are the actual functions that the LLM will use, as well as like the known functions here. So that's kind of all the setup of it. You can see that was like what, 4 blocks of code, a few functions, 1 class. Not a lot to get this up and running. And it's really simple. So I'm gonna run this new one again. It's what states do or does Ohio border? And you can see here, it's really cool. Like it's gonna go ahead and
Oh,
not
it
work.
it did that. So this is something that can happen, which is makes
Yes.
sense, right? You're using GPT 3.5, and
Mm-hmm.
we actually observed this before, which is like the first component actually finished. It actually did figure out, oh, I should calculate states that share borders with Ohio, take an action. But before I take an action, I should pause. And it the LLM seems to have taken that very literally and actually paused without taking a further action. So sometimes we've noticed like the pause statement can actually cause the streaming call to stop. So it's kind of interesting on that.
It's sure it gets confused. So let's run it again here. Oh, it's still not liking this. What is happening? Let's try one of the other ones. You can see here they were running before. Let's calculate the square root of 256. There we go. Now it's working. Something about that Ohio one, it was getting confused. But you can see here that same kind of process that we showed from the paper here, we get the thought, like the LM is a little bit cocky there. It says I can easily calculate the square root of 256. It goes and it calls the
Confident.
calculate. Yeah, it is. Um, and then it goes ahead and then runs the action. You can see here, it's the observation here. So it's observing the output of that action and then goes ahead and gives us the answer. So that's the gist of it. It's really straightforward. You can imagine this being used for a variety of different applications here, but I think the point that Aman and I really wanted to show here was that it's can be done with a few lines of code from scratch. Like you don't really need anything fancy to do it. You just need that check completion from OpenAI and you're off and running.
Yeah, totally. And you have an interesting question here actually, which is what happens if you skip the pause?
That's really a good question. I did not test that. We can do it live, see what happens. I think I would have guessed that the LM might try to start respond before it should. But I'm down to do a little live experimenting. Let's see what
Did you run
happens.
that code block, the one when you reboot the pause?
Yep, I thought I did, but
Okay.
let's do it again
Okay.
just to be sure.
Yeah.
Run the same one here. Let's see what happens. Oh, it's still
Still has
pausing.
a pause. Hmm.
It might be in one of my queries. No.
Yeah, you might have to rerun because that's just a prompt definition. You might need to rerun where that's being
Okay.
called, right? In your yeah, in this is it there.
Just run them all. No, just no. Here's that's just the class, and that gets called in here. So I think it was this one that needed to be rerun.
Yeah.
And I actually think the first time I didn't remove it from the initial guidelines, and I think that could have also contributed to our problem. So it could
Yeah.
also be
So
for like the the functions that take a long time too. So something like just doing this kind of simple calculate might it's a really fast operation. Doing some kind of retrieval might maybe even take longer. So I could see that also causing different results.
yeah, totally. I mean, when this paper came out, the latency of the models was also a lot slower, and yeah, I do think that like the takeaway here is the technique is very valuable to like decompose the thought, observation, and action, and how you do that, how you construct it together is yeah probably requires some prompt engineering as well.
Totally. Yeah. But really good example. We have the notebook. It was shared in the chat. Definitely try it out. Um, but with that, we can go into some prompting techniques. Aman, did you want to share from, or you want me to continue to share?
Yeah, I can go ahead and share. So we were going to go a little bit further into another but was kind of interesting. So I think main takeaway from the notebook is just it's so simple to stand up your own sort of agent if you're trying to do anything that requires multi-hop. We wanted to just do a little bit of a deeper dive into a couple more interesting prompt techniques. And actually, before diving in, we'd love people's feedback, during or after this paper read, of if you wanted to see more of, if you want us to do a deeper dive, you want to see more content like this when it comes to, practical examples of other prompting techniques. That could be really amazing to know from folks as well. So cool. So we're going to dive a little bit deeper into reflection. So this could easily be its own topic as well. It's another great paper on prompting. So the interesting thing about reflection, so this is again another a paper that it came out some time back, in 2022, 2023. And it sort of builds off of ReAct, Two Former, and a few of the other sort of like well-known papers in the space that try to get agents to use tools. The main so they've also called out a number of components here. You have the actor, evaluator, but the main one that they're kind of calling out is self-reflection, and then memory, which you can kind of think of as state. And we'll kind of go into an example of how that works as well. So I have some example logs from the reflection run, so you folks can kind of see how that works practically. But the idea here is it's kind of similar to ReAct in that don't just take an action right away. Think about basically generate some sort of thought of like what do I want to go do next, And then self-reflection says, hey, what do I know already about the context that I've been provided to try to go figure out what to do next. And the main, and yeah, I think like some of the pros here, it really does feel a lot more human-like, especially because the data set that we're going to go through, it's less, I think less interesting on like multi-hop question answering, more interesting on problem solving. So this is like more kind of like chaining problems together to accomplish a task. And then yeah, continuously improving itself by, basically this sort of self-reinforcing cycle of creating an action and then going back and reflecting on it. Anything else to add here, Salian, on a reflection so far?
No, I would really just tie back to what we said in the beginning about like the mimicking of human intelligence. And I think like the key thing here is like, humans make mistakes, right? And then what do we do when we don't get something right? We kind of reflect on it and then we take a new approach. And that's what it's doing is, it's taking an initial go at the problem. If it's not quite right, it's looking at that and kind of recalibrating and taking another go at it. So I think it's kind of expanding on that concept a lot, which I think is why it's so powerful.
Yep. Totally. And then great points on like evaluation. Evaluation is a core component here. So once the action is taken, go back and assess, did I make the right action? It's something we think about a lot as humans as well. Like, did I do the right thing?
Yeah.
What can I learn from this? Right. Like, sometimes it keeps us up at night. Oh, what about that thing I did?
It's
And
definitely
that
relatable.
can, yeah, exactly. Yeah. LLMs have feelings too, if you program them to. So complex evaluation. So I think like so this actually adds like a fair amount of like kind of open-ended complexity to the LLM call that you're making. And by that I mean by giving it's actually pretty tough to do to like evaluate an action the LLM has already taken, go back. It's basically like performing that same action again of like, did I do the right thing? It's going to go back and reflect on that. And I think what's kind of interesting, and I'd like to go a little bit further into reflection to prove this, but it does seem like that can sometimes cause the threat, the sort of the prompt to like break, or that the LLM to actually the
Mm.
response to break at times, because it ends up almost looking like recursive logic. It sort of gets stuck into like self-reflection, evaluate, and then you're trying to get it to take an action, maybe, but it kind of gets into like decision paralysis at times, which is kind of interesting to think about. So let's go through. Let's make it a little bit more tangible, and we'll link. There's an interesting. The paper is and GitHub repo is open source. There is a great blog post that the author on the paper put out that makes it super readable. And again, you can kind of see, hey, this is how I don't know, like this is how reflection performs on Hotbot QA, and then also AlfWorld. And so we'll actually talk a little bit about AlfWorld, and I'll drop this paper as well. Okay, awesome, it's already in there. So what's kind of interesting is AlfWorld is this interesting data set, which it's kind of just easier to read about. I think I've got it up here. So it's this interesting data set, which it contains interactive text world environments, which means it's kind of like an escape room.
Yeah.
Is how I would think about it. And if you go through, we can read a little bit of it. It's not going to be super readable. I apologize, but I'll try and read out some of this. But it's like you're in the middle of a room, looking around you. You see these things: a cabinet, a countertop. So it's kind of describing an environment, and it says, okay, now figure out these are the things around you. I need you to perform some action. I need you to clean this with that. So it's kind of like this like narrative script of make some observations, perform an action, and you're trying to basically get the LLM to kind of like the old style like RPG games, respond with text of what to go do next. You kind of want it to like make it work its way out of this world, and not actually, but more take some action in the environment that it's allowed to take. And if it does that, it gets a reward, and it gets kind of the next kind of piece of the puzzle here to go and solve. So that's like the main data set that reflection kind of calls out. They have the Hotbot QA runs. I just think the AlfWorld ones are kind of interesting, and where self-reflection really shines. So any questions or I guess any thoughts on that one, Sally, so far?
No, I think the only thing I would call out is this one is one of the decision making data sets that they also used in React. So it's
Mhm.
kind of cool to
Yeah,
kind of see it being used here. It's a little bit of that like one-to-one kind of comparison.
totally. Yeah. And it's interesting because like again, hop QA, multi-hop questions, go figure out an answer, use a tool or the equivalent of like a tool, go figure out, what you need to actually perform an action. Um, AlphaWorld has a little bit of that, but AlphaWorld is primarily in this data set, mostly focuses on, you know, making observations about an environment to kind of almost like narratively try and solve its way through it. So for the agent to solve its way through it. Um, so really really interesting. I think main takeaways here is reflection does seem to be does seem to perform quite well on AlphaWorld. We can definitely spend a lot more time. Yeah, but it's kind of sequential decision making is the word I was looking for. So it's not just question answering; it's actually making decisions in a certain order. Um, and then they actually also call out React plus reflection significantly outperforms React by completing 130 out of the 134 tasks. So what's interesting is the success rate on AlphaWorld goes up significantly when using self-reflection. So I thought that was kind of interesting. Like, React is great at that. What should I go do next? Kind of and take an action.
Mm-hmm.
AlphaWorld is given the context I have, what's the right next action to take. So it's sort of like these prompting techniques kind of play off of each other as well.
Yeah, and I think it just a call out just to kind of put it in. You said it was what one something they got it
Yeah,
got right.
one
It was
34. I mean, pretty high number of tasks. I think it performed correctly. 130 out of 134.
yeah, it was in like the 50s range for React alone. So just kind
Mhm.
of giving that kind of comparison of it definitely improves it, but not by a small amount. Like we're talking a large amount.
Yeah. One note is that the technique does involve what's called like trial numbers, which is it does allow like this data set kind of allows the LLM to kind of go back into a loop as well. So it kind of gets to see and learn
Mhm.
from the environment itself as well. So those are what the trials look like. So that's how this data set, this data set is sort of like based on number of trials. So it learns about the world through each trial. So you can see the successive number of trials going up. They score it up to 10 in the logs over here. So you can actually see this is what the code looks like when the output log looks like, which is I'll try and zoom in here to make it a little bit more readable. But it's basically looking at based on the first scene, the first environment, did it succeed? Yes or not? And then you'll see the memory about the environment too. In this environment, my plan was to find a plate, then clean it with a sink basin, then put it on the countertop. However, I forgot to put the plate in or on the countertop after cleaning it. I should have gone to this. So it's sort of similar. It's like this inner monologue, narration of like, well, I should have done this better. And then as you go further, you actually have the run logs here. It does get to run through that environment multiple times, which is what gets it, kind of successively improve. So it kind of gets to learn from itself over time. It's like I've seen this scenario before. So you're kind of answering from like your parametric. It's the non-parametric, but like context memory, as opposed to
Mm-hmm.
having to solve it from like a zero shot from the get go.
Super cool. I really
Yeah.
love when they include the repo like they did with this paper here, so we could actually dig into those logs.
Yeah, totally. I unfortunately I couldn't get a nice notebook up and running right before this. If someone else manages to do that, please do feel free to share it in community. Would love to take a look. I have it running kind of locally, but again, pretty straightforward code examples here. You're basically just defining. I think this is okay. Yeah, so this is sort of a few shot example of the of what the output looks like. So it's you're in the middle of the room. These are what you see and says, think, okay, to solve this task, I need to find and take a mug, then put it on the coffee machine. Okay. Then it looks around and then it says, okay, here's the next part of the environment. Okay. And so it kind of just keeps working through in that way. But yeah, pretty straightforward, in terms of implementation. I didn't see an example of, so I mean, the available agents types include React and reflection strategies. So you can kind of combine the two in the code example as well. So you kind of get an agent that works out of the box with React and reflection. Um, awesome. We do have a couple more, but I just wanted to kind of, I feel like these were kind of the two main data sets. And then do we want to kind of briefly touch on like chain of thought, and then we can come back
Yeah.
in a future, paper read.
Totally. Yeah, like let us know, folks, if you want to see more reflection. We can even have that coding example. Let us know. We can follow up. But yeah, the other one I just want to call it was chain of thought because it is used in the paper, and just make sure that everyone understands how that works. And so basically, it prompts the LLM to verbalize its intermediate reasoning. If you remember from that first example from the beginning when we had all of them up, you could see that the LLM's thought process was there. So it definitely helps with the model handling like any multi-step reasoning, but it then also makes it more transparent, similar to React, just so that we can kind of see that log. But again, we do have that fact hallucination problem because it's still relying only on the model's internal knowledge, which can lead to hallucination. So that's kind of where React has that step above because of the actions we're bringing in that external info. So calling that out there, like React doesn't interact with external, but one thing that's important is it actually uses a slight variation of chain of thought in the papers. They use chain of thought SE, which is self something. I'm blinking on the word right now. But basically, the idea here is it has those multiple reasoning paths, and then it uses this kind of like consensus like approach to then determine the most likely correct answer. So it is slightly different. It has a slight edge above the traditional chain of thought, but that is the actual method that is used to compare in the React paper itself.
Yeah,
Self-consistency.
I
Thank
think,
you. I was like,
yeah, so
I
mhm.
was like,
Yeah,
which
yeah,
one is it?
right. Yeah. And I think that's interesting, right? It's like a variation on a fundamental sort of prompting technique. So,
Totally.
yeah.
And it seems to be pretty powerful based off some of the results that I saw. But yeah, that's the chain of thought. I think it's just worthwhile noting how that works.
Yeah, awesome. Well, I hope that this was at least helpful for folks, who are maybe just getting started with agents and experimenting with them. Hopefully, makes them more tractable, easier to understand. And as you can see, the code examples are not super complicated. They're actually pretty easy to pick up once you take a look at the GitHub repo. You don't need to use too many like complex abstractions, and you'll be able to like understand the code more deeply if you're seeing it yourself. And a lot of it just comes down to stringing these prompting techniques together, and of course tweaking the prompts for your use case. That's my takeaway, at least for this. I guess anything more to add there, Sally Ann?
No, I think you hit everything. I think my main ones too was like it's a combination of efforts to get the LLM really what you want, which is I'm sure I've experienced that definitely to be the case. But
Yeah,
yeah, thanks everyone.
yeah, and this one was really fun. So if folks want to see more of this type of paper read, please do let us know. I'd love to kind of come back and maybe cover reflection or chain of thought, self consistency in more depth as well, or some of the other more emerging prompting techniques.
Totally, I feels like new ones every day.
Yeah, cool. Thanks everyone. Thanks,
Thanks
Sally.
all. Bye.